Hello and welcome to our AI project presentation. Now let's discuss the project, a real-time sign language interpreter. The idea was simple but powerful. Break communication barriers and make the world a little more inclusive and accessible for the hearing and speech impaired. Our objective wasn't just to recognize signs, it was to do it intelligently and ethically. We focused purely on hand gestures, ensuring that the system works smoothly and in real time, even on resource constrained devices. When we started, we made some key assumptions. Users perform the gesture using right hand only. The system is trained primarily on a specific sign language, for example ASL, here, and may not generalize across all regional sign languages. Real time performance may vary based on hardware capabilities. With that mindset, let's dive into the technical journey we took. Initially, we had two main approaches. One was image-based processing using CNN, and the other was extracting 2D hand landmarks using MediaPipe. We realized pretty quickly that CNNs would make the model pick up unwanted features like hand color, skin texture, even background noise, which could easily bias the predictions that would go against our goal of being inclusive, so we ruled that out. Instead, we chose to use MediaPipe, which extracts pure hand landmarks, just the key points of the hand, completely independent of skin color, lighting, or background. This was a big win for making the model fair and robust. We also normalized the landmark coordinates so that the model only learns the actual gesture, nothing else. To begin with, we focused on static gestures. We created a custom dataset, thoroughly preprocessed it, and integrated it into a working model. However, based on feedback and a little ambition, we expanded our scope and desired to explore dynamic gestures as well to handle sequences over time. We turned to an LSTM model. The logic was simple. Capture 20 frames for each gesture and let the LSTM figure out if it's a dynamic or static motion and predict the intended word. But reality struck. LSTMs need huge datasets to perform well. Given our resource limits, the accuracy wasn't what we hoped for. So we made a practical decision. We pivoted back to refining our static gesture model and focused on doing it right. At that point, we compared two options, ANN and random forest. We trained and tested both, looking at accuracy, performance, and model weight. While random forest was quite accurate, it was too heavy and made the interface laggy. On the other hand, ANN gave us great accuracy with a lightweight footprint, making it perfect for our model. Moving to the interface, we built a smart system. Each correctly predicted alphabet gets stored in a buffer. When a space gesture is made, the buffer treats it as a word and updates the sentence. We added some cool features too. If the hand moves out of a frame, a 5-second timer starts. If no gesture is detected within that time, the sequence is finalized and sent to the ESP32 for display, and I'll show you how that works in a bit. Initially, we also thought of using BERT for grammar correction because in sign language, auxiliary words like is, are, etc. are often skipped. But BERT was huge, laggy, and sometimes made nonsense corrections, so instead we made a smarter move. We added an option where users can look up the meaning of the predicted word using APIs, keeping the system lightweight and practical. Performance was still a challenge, so we implemented multi-threading. Now predictions, API calls, and ESP32 communications happen on separate threads. This boosted performance massively. The camera runs smoothly, gestures feel real time, and there is no noticeable lag. Overall, this project taught us so much, from exploring deep models to creating custom datasets, balancing performance, and designing an interface that's both smart and inclusive. And more than just the technical effort, this project reflects our intent to create meaningful solutions that truly make a difference. Thank you so much for your time. Now Let's quickly go through the working video of our project.